All right, so keep in mind, so this is chapter 15, number 14. Okay. Oops. So keep in mind that what they're saying, so you have this equation, right, is in equilibrium with this. Okay. And they're telling you that Kc is equal to 3.1 times 10 to the negative 5. Let's talk about A first. So A asks you which substance predominates at equilibrium. How do you figure that out? Use the Kc. And Kc is less than 1, which means what's favored? The reverse reaction. So if the reverse reaction is favored, that means you're going to have more I2 at equilibrium than you are going to have 2I. Correct? Jackie, are you with me there?
So if Kc is above 1, that means reactants are favored, so it's reversed.
Right, because remember, Kc is basically like the concentration of your products over the concentration of your reactants, right? I personally think it's somewhat easier to understand it mathematically, right? Like if my numerator's bigger, my answer is going to be above 1. If my numerator's smaller, my answer is going to be below 1. Since the numerator represents products, then if Kc is greater than 1, that means that I have more products at equilibrium than I do reactants, mathematically. If Kc is less than 1, no, if Kc is greater than 1, that means I'm favoring the forward reaction because Kc is greater than 1, so I have more products. If Kc is less than 1, my numerator is smaller than my denominator, which means I have less products than I have reactants. It's favoring the reverse reaction. Okay? So then if you look at B, it says, assuming both forward and reverse are elementary processes, which reaction has the larger rate constant, forward or reverse?
I just thought, that's what I did. I wrote out the labels, like each separate way, and then I just thought that if for the reverse reaction, since the reactant would be squared.
Well, think about it this way. Isn't it?
So the K would have to be smaller.
Tell me if I'm right here. Am I recalling this correctly? That Kc is actually little kf divided by little kr?
Is that a thing?
That's a thing. Like if you go way back to the beginning, because technically, using what you just did, Jackie, so, because we're looking at two equations simultaneously, right?
Yeah.
So if you look at these, the forward reaction, you use your reactants, right? So for the forward reaction, for the forward reaction, rate equals little kf times I squared, right? They said it's an elementary process, right? That's for forward. For reverse, kr is actually like the, what is that, f to the minus 1? Is that how I write that? Like the inverse.
Yeah.
It's that times that squared. Then we set them equal to each other and all this stuff. Anyway, long story short, the way they get big K is the ratio of kf over kr.
But isn't it asking about rate constant?
These are little k's,
No.
right? This is the relationship between big K and the little k's, okay? Big K equals little kf divided by little kr, which means if big K is less than 1, little kr has to be bigger than little kf.
That's not how I did it, but that makes sense.
Does that make sense? I got the kf over kr part right. Okay. That was so long ago, I don't remember. There's a lot of k's to keep track of. Yeah? Okay. No pun intended. Okay. All right. Get it? Okay. You're just totally enemies. All right. Next. Can we move to chapter 16 now?
Yeah, sure. I prefer.
How do you know you haven't done it yet?
Should 16? I did do it.
Oh, I thought you said you were doing it on Sunday.
Oh, that's 15.
Oh, got it. All right. Chapter 16. What questions do we have?
44D.
Oh, who else wants to discuss 44D?
I'll do it.
And then by extension,
46.
4060. Am I right? You think you got it? What'd you get? Huh?
For 44D, I got pH is 1.89.
Good job. All right. I am going to actually take the time to do 44D because I can tell you guys this is like a pretty good AP question. And sometimes, just so you know, they actually do this in multiple choice, but with nice numbers, okay? Like usually where it'll be like 0.2 and like 50 milliliters or so, like something where you're multiplying 2 and 5, you know, where you could technically do it in your head. You just move the decimal, all that fun stuff, right? Okay, so let's just look at this for a second. You have two solutions. All right, so we're going to do 44D here. You have two solutions, okay? You have 50 milliliters of 0.020 molar HCl, right? And you have 125 milliliters of 0.010 molar HI. And what are they asking you to find? pH. So they want to know what the pH equals. But in order to know what the pH equals, you need to know what?
The concentration.
Of H+. Right? We need that to find pH. Okay? Where is our H+ concentration coming from? Where are we getting H+ from? This and this. They are both what? Strong acids, which means they completely dissociate. Now, which means all of the moles of acid are becoming moles of hydrogen ions because it's a 1:1:1 ratio, correct? However, visualize for a second. You're going to be literally combining these. Nope. Which means, do me a favor, go back. What is concentration? You said the concentration of H+. What do we mean by concentration? Our favorite word, molarity. And what does molarity equal?
Moles per liter.
Moles per liter. We know our moles are coming from up there, like our acids. But tell me about our liters of our final solution. We need to add them together. So 50 plus 125 is going to be 175, right? Which means which means, I know what I'm doing. Okay. Which means we're going to put 0.175 liters down here, correct?
Yes.
Okay. The question is, where do we get that?
The low rate of the concentrations that we're getting.
What do we do? We just plug them in?
No.
Do we just use 0.020 and 0.010? Why not?
Because that's for all of it. We just need H. H plus,
That
right?
number is some number X over
Yeah.
0.05.
We have molarity and we have volume. What do we need? Moles. This is our favorite thing to do that we're so great at, said no chemistry teacher this year ever. Molarity, that thing that we struggle with, right? You're just done today, aren't you? I can tell. No, not yet. It's okay. I'm feeling it. I'm there with you, but I need to break out the pom-poms anyway and be excited. So there we go. Fake cheerleading right now happening. What do we do, people? Yay! I know. You'll want to participate so that I don't do that more often. What are we going to need to do?
We have to find the moles.
Find the moles. So we need to do HCl. We're going to take the molarity times 0.050 liters, and we're going to get an answer. And then we're going to do it for HI. Go ahead, do it for HI. Get an answer. Come on. I want to hear your fingers tapping on those calculators. Oh, good God.
I keep saying I'm going, and I keep going.
As long as you bring it to the AP test. I mean, it's so quiet in here. I can hear the heating vent. Especially in this room. Like, we're never quiet. All right. What do we have here for HCl?
0.001.
0.001 moles. And what do we have for HI?
0.00125.
And what are we going to do with those? Add them together. So it's going to be 0.00225 moles. Is that the air conditioning then, or is it raining really hard? Oh. Woo! Okay. So this is going to be the most depressing video to watch ever. We're all like, huh? Okay. What do we do with this now?
So, do you mind it?
To find our molarity of H plus, right? So what does that equal? 0.0129. Oops. That's 0.0129 molar, right? And that's our hydrogen ion concentration. Because I want to point out why. Because for a strong acid, strong acids do what? Fully dissociate, which means it's a one-way arrow, correct? And it's a 1-to-1-to-1. So however many moles of HCl we had, we also have the same number of moles of H+. That's why we can make that assumption. Are you with me there? Make sure you're with me because that's going to be important on 46D.
I'm trying.
So my son, Quinn, when he doesn't understand things, he goes, "What you say?" Just like that.
Wait, that's a younger one?
Yeah, like, and it's like he has a scowl on his face, like, what you say? Like, he cracks us up. That's what you reminded me of. What you say? He's usually annoyed that he can't understand you.
I just like don't know how I didn't hear.
I know.
I heard it. I just like.
You're underwater.
Yeah.
All right, you'll go back and watch the video, and you'll be like, she was speaking clear as day. Anyway, what I'm saying was this. Let me highlight. Pay attention, Mandy girl. HCl is a strong acid, which means it fully dissociates, which means our math told us that we have 0.001 moles of HCl. But because it's a 1-to-1-to-1 ratio in our balanced equation, that also means we have 0.001 moles of all of these. That's an important aspect of 46D. Okay? So now you guys, now that we have our 0.0129 molar as our H plus concentration, what do we need to do?
Take the negative log of it.
We need to take the negative log of 0.0129 because that will give us our pH.
Why do we have HI? I'm confused.
We used it also because we added them together. I just like,
Left it out.
well, I didn't do two equations. I could. Allow me. Hi. Never gets old. Okay, are you with me there? So then we've taken these two numbers and added them together to get 0.00225 moles of H plus, which is the same thing we have there, which then we used up here, divided by our total volume, got 0.0129 molar, plugged it into negative log, and if you do that, you should get a pH of 1.89. Yeah? Okay. Allow me to alert you to why 46D is harder. Look at 46D real quick. It's very similar. You're combining two bases, but you're going to have to be careful here because one of them is this, which means when it dissociates, what do you make? Ba 2 plus and 2 OH minus. You're going to have to account for that 2. It's not a 1-to-1-to-1 in this one. Okay? So I'm not going to say more. I'm going to give you that little hint. Jackie, I feel like maybe you should be back in your usual chair. You're like not even looking. I know. Let me go next to Mandy so that you could at least face forward. Okay. So you're going to have to deal with that too. Okay? But otherwise, overall, it's going to be a similar process. But that, you guys, this is the type of like multiple choice question they like to ask. Like, if you have 0.1 molar BaOH2, what's your hydroxide ion concentration? And that's a great multiple choice question. Like, that doesn't involve a calculator. That involves stoichiometry. So I'm not going to say more. When it's time to do the reflection, you can look at it. Like, look at that one again, try again. Like, if you think you did it, make sure you accounted for the 2. Okay, other question. Was it 54 or 56? Yeah. I love 54. Which is good, and that's not fake pom-pomming. That's real. It's a good question. Okay. All right, so 0.100 molar bromoacetic acid. Let me tell you where I'm going to be on May 9th while you're all taking your AP exam.
Where?
At the eye doctor. Just kidding.
Isn't that your anniversary or something?
May 8th, the day before.
Who's our proctor?
I don't know. I don't figure any of that out. I'm like literally barely allowed to have contact with you that day. I'll be outside whatever room giving you like high fives, but I cannot speak at the minute you walk in the room. I cannot speak to you.
Really?
Yeah.
I don't want to. Where is it?
I don't know. There's so many of you taking it. What you say? Okay. No. Okay. Not an option.
No, I can't have tennis conferences. There will be no shutting down.
What about Marianne?
Yeah.
Well, Marianne, you can shut
Okay.
down.
Marianne doesn't
All right. Now, pay attention. Are you ready? Okay. Here we go. This is basically what they're giving you, correct?
Yeah.
And they're asking you to find the concentrations of everything and Ka. How are you supposed to do that with this information? You're like, I don't know. That's why we're asking you. Okay, well, let's start here. What is percent ionization?
It's
What's the formula?
it's H plus EQ over H plus the concentration.
H3O.
Oh yeah,
That's fine. You could call it H plus.
and then the initial on the bottom.
Of?
The concentration.
The acid to point.
Yes.
So, let's take a minute. What do we have here? What do we know? We know 13.2, right?
Yes.
Equals this over, do we know this?
Yes.
We do. 0.100 times 100. How about I give you a minute to find H plus? Okay? So rework this and find your hydrogen ion concentration for me, please.
Oh.
Can you do that? Am I in your way by sitting here? Okay. Just don't want Andy to feel lonely. I think this is kind of visible on the board, maybe a little bit. We're all winners, you guys. We're all winners. Sierra just said it's not a competition.
Everything's a competition.
Boo. Really isn't. The end result is the same for everybody.
Yeah, but there's a competition.
You're born, you live, you die.
Dr. Peacock, you know how
That's
people,
really depressing.
Just want to
Like, you look.
Same outcome.
you know how people say like no matter if you're rich or like poor, your grave is still the same size.
Your what?
Like,
Brain?
the grave,
Oh, your grave. Got it. Yes, yes.
and then your two kings are.
Well, actually, your grave is wild.
Right. Do you know that Einstein had an abnormally small brain?
It's wider though, isn't
You know, the brain is good.
Do you want to read a really great book over the summer? I would highly recommend Driving Mr. Albert. It's a good book. It's the true story of Einstein's brain and how it got delivered back to his family in a bowl of formaldehyde decades after.
What was the point of doing it?
When Einstein died, they wanted to do research on his brain to see what made him such a genius, right? But then there was fighting within the family of did they want him to, like, you know, do this research with his brain or not.
Yeah.
And due to the research, due to the controversy, the research got put on hold. So the scientist who was in charge of his brain, because it was like the 60s, literally put his brain in a Tupperware container filled with formaldehyde on a shelf in his lab to keep it good until they got the okay to do research. Well, like 30 years later, he decides to retire. He still has the brain. It's been sitting on the shelf the whole time.
For 30 years?
30 years. This is a true story. Look it up. It's a great book. He's from New Jersey. He wants to get the brain back to Einstein's family, who lives in California, but he doesn't want to send it to the mail because, God forbid, what if it gets lost, damaged, something? You know, like he wants them to get the brain intact. So he hires, he's like a 78-year-old man, he hires a journalist and rents a convertible and has this journalist drive him across country with the two of them in the car and Einstein's brain in the trunk. And the whole book is about their journey, historical stuff about Einstein, and all that. It's a very interesting book. Driving Mr. Albert. When you're done with the...
Did they do any research on the brain?
Read the book. Find out.
I thought the physician cut it, like the physician who took out Einstein's brain illegally, kind of.
Yeah.
I thought he cut it up and then sent pieces to other researchers.
Well, this might have been what was left. Like after... Maybe that was when the family was like, whoa, 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 stop. All right. So, anyway. Good thing to do after the AP test. Read a book. Not about chemistry. All right. What's our hydrogen ion concentration? Right, 0.0132. Okay. When is this our hydrogen ion concentration?
Yes, that's at equilibrium.
Equilibrium.
Right, when do we have hydrogen ion concentration? At equilibrium. I mean, well, first of all, little hint here. That is the equation, right? Okay. Now, if we know our H plus at equilibrium, what else do we know?
Our BrCH2COO.
Oops, hold on, I'm highlighting. Yes. In other words, our conjugate base,
Yeah.
right?
Yeah.
Don't we know this at equilibrium also?
Yes. It's the same thing.
Let's talk about why. I know. I really badly, let me just tell you, I'm going to, really badly last night while I was doing homework, this homework, I wanted to write the word acid and not write out this whole thing. And because you don't need to. But I was like, no, if I write that, they're not going to understand where I'm getting it from, so I have to write out the whole thing. Who are our products? H3O plus and BrCH2COOH.
No H.
Or no H. No H. Minus. Okay. Now, keep in mind, this is the same as,
The concentration. Oh, yeah.
right, H plus, okay? So, what are we going to do here, you guys? Oh, just kidding. Ice, baby. Okay. I'm not well justified in terms of margins, but we'll make it work. I know it's a big problem. I mean, like, it's a lot that you have to do. I didn't mean skipping the ice chart is a big problem.
I took up 8 classes.
I bet. Okay. So what do we know?
So we know the initial for for BRC.
Okay, right. Like, fill in. Take a minute. Fill in. What do you know? You know a lot. Fill it in. Did you watch the video from the other day? You did? Okay. I posted it yesterday. So I felt bad that I didn't post it right away. You rewatched?
No.
Oh. I was going to be so proud.
Last class, I understood last class. Which one was it?
Well, this is a big problem. Like, it's a lot. But you guys, because it's a lot, do you know what this is a good example of? A free response question. A 23-minute one. And this is probably like half of the 23 minutes. Because then they're going to throw in some other stuff. So really, like, this is why, like, it's hitting a lot of concepts. Okay? Think it through. It's hitting molarity. It's hitting weak acids. It's hitting equilibrium. It's hitting all these things.
Just remember that you're prepared, and even if you don't pass, you're going to go into college having so much more than most students do. You'll go into your first year and you'll just breeze through it while everybody else is struggling. So if you don't pass, you still got the experience.
Yep, and that's what Eric just said. Anna's brother was just
I
here.
saw him in the office.
He said he goes, and he said, I don't think he would care. He was like, I'm upset that I got a 3. He's like, but even if I only got a 3, he's like, chemistry was a breeze my freshman year. Like, that's what you want.
Yeah.
It's not reassuring.
What?
That him and Mel got a 3.
I'm better this year. I'm better.
Well, I hope I'm better.
You're getting, like, no, I'm going to be honest. When we've been doing this, I'm like, God, I'm killing it this year. Like, I'm explaining this really well. Like, in the past, I'm like, God, this is hard to explain. But this year, I'm, like, crushing this, where I'm not messing up. So you're getting, like,
Everybody's
you know, well, I'm not going to go that far. But I can at least feel like I'm doing a better job where those 3s maybe can be 4s now.
Well, don't colleges take 3s?
It depends on the school.
Mine?
They're all different.
I didn't take a single AP class in high school, and now I run a high school. So you are all already smarter than I was. So you're going to do great.
I didn't take AP Chem.
No, I didn't take AP, but we only had 2 offerings, and if you took one, you had to take the other. And I wanted AP Social Studies.
Smarter
but
than
I had to
me.
do the
You're the
English,
new and
I had to read
improved
8
version.
books, I let that happen. So I didn't do it.
The 2.0 pecan.
Yeah. Oh, yeah. I mean, yeah.
Yeah.
You
No,
can
I
be
was.
successful even when you fail, for sure.
No, that wasn't my GPA. That's not what I. No, as soon as when I said it, I was like, oh, she thinks I mean that was my GPA. No, I'm saying Amanda's the new and improved version of me. She's the 2.0.
You're the 2.0. Got it.
So why not? We're twins.
All right. So here we go. What do we have?
We have.
I don't know if we have 0.
What's in here? Like, can we fill out this part? We know it.
That's going to be 0.0.
0, 1, 3, 2. What's this? Also 0.0132. Which means, what's up here in the initial?
0.
0, 0. Oops.
Wait, isn't? And then it's just plus.
If I sign up for an exam and don't go, not this one, I'm serious. I'm
You're
gonna do this one.
$50 now.
I know, but I'm talking about lit, because
No, they don't care.
Joey's gonna take it.
Like, you paid. They don't care.
Because we literally have not prepared for that at all.
All right. Yeah, but it's a lot of essay writing and stuff. You could probably do it.
Yeah, I feel like.
All right. So, what else do we know?
The initial for VR.
What is this? 6-8?
868.
8-6-8. And then what do we do with those?
What's the question is equilibrium expression? Well, I don't know
Right.
what the question is, but I'm guessing.
yeah.
Okay. A. What did the, I don't remember. Oh, yeah, what the question asked was for us to find this, this, and then also this. So what do we do? 0.0132 times 0.0132. And you guys, I'm being serious when I say that. Like, this year, this is the clearest I've ever explained, like, chapter 16. Like, I'm like, okay, I feel like it's a lot, but I feel like it's being, like, I'm presenting it to you in a way that, like, I know if you just practice it, you could potentially do all right with it. Do you know what I mean?
Yeah.
Like, there are some years where I explain things, I'm like, oh God, please don't ask a question. I don't know if I'm going to be able to answer your question. This year, I'm prepared to answer questions. Sort of. And then you get an answer, and that's that. No, there's no unit for KA. So what's our answer?
2.0.
Oh, you did the.
2.0 times 10 to the negative 3. And it's okay if you have 2.01. Like, don't stress out about sig digs until they tell you to. Just don't use like 8 numbers after the decimal. You know, like call it somewhere based on some data you're given. The data we're given, we have 3 numbers, so it would be reasonable to use 3. Okay. Yeah.
So, like the K, like I get like P is when it's pressure. What's the difference between A, like C is the concentration.
Okay. Yeah. So we've looked at this, right? This is the generic. Everything we're doing could be considered KEQ.
Okay.
Then there's, okay, so hold on. Let's make a flow chart. Ooh. Okay, so KEQ. Then there's 2 ways to measure that. KC and KP. This is for gases. This is for solutions and gases. Because you can measure concentration of gases, right? Okay. And P is for pressure, right? Okay. Then, like, we've talked about KW. The W is water, right? We've talked about KA. The A is acid. Today we're going to talk about KB. The B is base. In chapter 17 we're going to talk about KSP. But they're all just specific versions of the same thing. Does that make sense?
Yeah.
Okay.
They're all found in
What?
They're all found
Yeah. It's just that when we're specifically looking at acids, we call it Ka. You know? Kind of like we call you a name and we don't just say girl. This isn't Bird Box.
Yeah.
Okay. All right. Yeah, it was great. What? You didn't like it. Okay, we don't have time for this. All right, any other, hold on, time out. Any other homework questions? Or are we good? We're good. Okay, I'm not going to.